Section 5.6, find all real zeros of a polynomial function. And when you hear the word zero, remember that solution and x-intercept are all interchangeable here. So that's what we're looking for when we're looking for the zeros of a polynomial. We're going to look at the rational root theorem first, and this is going to give us all the possible roots of the polynomial. This just says if we have some polynomial in the form f of x, and it has integer coefficients, then every rational zero, or every root of this polynomial, can be written as what I have here in red, p over q. P is going to be the factors of the constant term, and then q is going to be the factors of the leading coefficient. So we're going to take all the factors of the constant term and put them over the factors of the leading coefficient. And that is going to give us all the possible roots of the polynomial. So from this list of the possible roots, we're going to use our graphing calculator to narrow down our search, because we could have a lot of possible roots, to find which ones are feasible, because they're not all the roots, they're just possible ones. So let's look at an example. If we're looking at this function right here, this x cubed plus 2x squared minus 11x minus 12, what we're first going to do is use the rational root theorem to find all the possible roots. And p is the factors of the constant term, just to remind you. And q is the factors of the leading coefficient. So we're going to find p over q. So first list all the factors of our constant. We have 12 there, and negative 12. So we're going to have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. And divide that by the factors of the leading coefficient. Well, our leading coefficient here is just 1, and the factors of 1 are 1. So really, I'm just dividing these all by 1. So these are all of the possible roots, plus or minus 1, 2, 3, 4, 6, and 12. So that's a lot to go through, and we don't want to try all those algebraically because it would take a while. So what you're going to do is look at the graph. So if you graph this, you're going to get something that looks like this graph right here. If we look at the roots, or the solutions, or x-intercepts, we see that we have, looks like maybe a negative 4, possibly a negative 1, and a positive 3. Now, these might look like they're crossing at that point, but when we get into more complicated polynomials, they might not cross perfectly over an integer. It might be a fraction, so you can't really see. But you're going to try what you think is close. So I'm just going to try with this negative 4 right here. And we're going to use synthetic division to check and see if that's a 0 or not. So negative 4 I'm going to try first. And fill in my coefficients here, 1, 2, negative 11, and negative 12, and go ahead and use synthetic division. Bring down the 1, 1 times 4, negative 4, 2 plus negative 4, negative 2, negative 2 times negative 4, 8. Add these two, negative 11 plus 8 is negative 3, negative 3 times a negative 4 is 12. We get a remainder 0, that means that it is a 0. So one of our factors is negative 4. So let's look at what we have left here. After we divided by that 0, we have left x squared minus 2x minus 3. So to find our remaining two zeros, because we know we have 3 of them here just by looking at the graph, we know one of them is negative 4. To find the other two, we can factor this. We know that this factors as the sign is negative, so it's plus or minus. Factors of 3 that subtract to give you 2. We have 3 and 1. And if you set those equal to 0 to find your remaining zeros, we get x is negative 1 and x equals 3. So your 3 zeros are x equals negative 4, x equals negative 1, and x equals 3. Now, when you get down to this step right here, you might have something that doesn't factor so well. So you have to remember back of other ways that you can find zeros. So you could do things like completing the square, or just go ahead and use the quadratic formula would probably be the easiest. So this is how you find the zeros of a polynomial.